and I'm going to do more. I'm going to do transcript. I caption it in English. See if it records. Oh, it does. Okay. So now we will have a transcript of everything that I've said, which is cool if you wanted to search it and be like, I know he said something about variables, but I don't know where it is in the video. I'll just search the transcript. That's cool, right? It is. I don't care what you think.
So like speech to text, like
yeah.
makes it searchable.
Yeah, and it also will, if you bring up Zoom and you turn on closed captioning, then it'll have an automated captioning of what I'm saying. So if, for whatever reason, you're hard of hearing and you haven't told me that, or you're at home and you have a 3-year-old who's sick and sleeping and you want to participate in class but you can't listen, then this would be a solution. I use that because that's my world right now. All right. I am recording, so I just recorded all of that. Nobody needs to know. And I'm going to start the slide. So this is week 2. No, it's not. This is day 2. Technically, it's week 2 because we missed the first day, right? But whatever. I'm going to change the maybe layout of Canvas to count this as week 1. So today what we're going to do is we're going to talk about variables, we're going to talk about constants, and we're going to talk about planning. My goal is to get through this in the first hour so that we have the second hour to do the project. The project is very quick, hopefully, or maybe it'll take you until next week to finish. I don't know. But it's a simple concept of a project that hopefully you can get through quickly. We'd like this to be out of the way. All right. So we talked last class about the idea of declaring a variable. You have to have a variable type. You have to have a variable name. And then when you declare it, you don't have to, but naturally you're going to set it equal to some value. If you don't give it a value, the value is generally just a 0, we talked about. If it's an integer, it's a 0. If it's a float, it's a 0.0. If it's a string, it's an empty string. There's just nothing there. And if it's a Boolean, the default value is false. When you're declaring a variable, there's a few things that you need to know. The rules are it must begin with a letter. So this is something that anybody who was creating passwords for accounts 15, 20 years ago will probably be familiar with. If you tried to start your password with a number, it wouldn't let you do it. You could have a number in your password, and we're encouraged to do so, but the number could not come first. And that's because with variables, the way that C++ and some other language works, they have to begin with a letter. Variables, the naming of variables may also only contain letters, numbers, and the underscore. You cannot put special characters into the name of a variable. Does that make sense? It has to be a legitimate letter, number, or the underscore. Now, the underscore is important because there's 2 ways that in best practice we name variables. Technically, you can name a variable however you want, as long as it's only consists of letters, numbers, and the underscore. However, in best practice, we have 2 approaches. We have what's called the camel case and what we call the snake case. Camel case, the first word of your variable is a lowercase word, or first letter of your character is a lowercase letter, and then any other word, second word, third word, starts with a capital. You also can't use spaces in the name of a variable. It can only be one constant, consistent, connected phrase, right? You can have as many words as you want, right? But it has to all be connected. Now, in camel case, every word that's not the first word has a capital letter. The reason this is important, when you're scrolling through your text, you want to be able to find your variables relatively quickly. You want to be able to isolate exactly what is a variable because those are the things that change and those are the things that you're working with as you go. For some people, putting a capital letter in helps you to read it quicker. right? It helps you to break apart the words, because camel case, if all of it was lowercase, I don't know what you might mess it up as, but it would be harder to find and harder to break up as words because you wouldn't have any designation. Snake case, for some people, it's easier to read because it feels like there's a space in between the words. Snake case gives you that space. If you had 15 words, you'd have 14 spaces. That's fine, right? If that was your variable name. The goal is to make it easier to read for you. For me as an individual, I use camel case just because that's the way that I learned. That's the easier way for me to process and find what I'm looking for. If you choose to use snake case, use snake case. I can read it just fine when I'm grading your stuff. If it makes it easier for you, that's what you should use. What I want you to not do is mix the two. Don't have some variables where you name them with camel case and some variables where you name them with snake case. It won't matter for most of our projects up front, but once we get into bigger projects, if I'm skimming through your stuff looking for a variable name, I'm either going to be looking for one or the other. And if you have them mixed, it's going to be hard for me to find. It's not probably going to affect your grade. It's just going to irritate me, which may affect your grade. I don't know. Who knows? The two other things that we want to talk about when we're coming up with a name for our variable. The name has to be descriptive, but you also want the name to be short. So the goal is to make the name of the variable as short as you can, where you actually still know what the variable is doing. So examples that I give are, let's say you have a game, and the game has 4 players, and all 4 players have a high score that they can have while they're playing the game. Your variable could be player 1, well, player underscore 1 underscore high underscore score, right? That could be the name of your variable. That's a pretty long variable name, though, but it would tell you exactly what it was. Your variable could also be P1HS. It's a really short variable name, but does it tell you exactly what that variable is? Maybe yes, maybe no, and it depends, right? If you're the only one working on the game and you know that P1HS is player 1 high score, and you know that you're never going to forget that, you can use it. I would put it in the comments and say that's what this is, but you can use it. But if you're working with other people, then you might want to do something like P1 high score, right? Or even P1H score. However you want to designate it. The goal is to make it as short as possible, but so that anyone who reads your code will understand what you're doing. Last class, I think I gave an example of a variable named blah. The reason I give the example of the variable named blah was because I was working with a group. We were making a game. We had one programmer who was a very, very good programmer. But when he ran into problems, his problem-solving method was to make up really, really quick solutions without thinking about how they affect everything else. So if he couldn't figure out what it was, he might make a variable named blah and then test changing that variable to see how it affected the game. When it worked, he never went back and re-changed the variable from blah. So when he passed that code to me and to our level designer, and we were reading through it, we were like, what does this blah variable do? And then he would have to tell us, and we'd be like, why would you name it blah? And he would have to say, because I'm lazy, right? But it took a lot of extra dialogue conversation. If he'd have just named it what the variable is doing, then we wouldn't have had to go through that transition. And it's not a huge deal if it's one variable and you have a team of 3 people. But if it's every variable you have and you're working on a team of 30 people, then you have a huge issue with communication. And it's going to take you 10 times as long to finish your code as it would if you just gave short and descriptive variable names. The last rule is that it cannot contain a keyword in C++. So we talked last class about the, what is going on? Get out of here. You. Great. cannot open the file. You can. We talked about the syntax, right? We talked about the lexicon. The lexicon is all of the words that C++ has that have meaning. These are all of the keywords that C++ has that have meanings. You can't name a variable any of these keywords. So if you were to try to make a variable and you wanted the variable to be named long, you would say long equals 17, right? C++ is going to give you an error because long is a keyword and you can't use it as a variable name. You don't need to memorize all of these. Usually it is very unlikely that you're going to use one of these accidentally, but it does happen. When it does, you're going to get an error. Just be aware that if you get an error that says keyword in use, then you just have to change your variable name. All right. So that's declaring a variable. Setting a variable is very similar. The only difference is you don't have to give it a type when you're setting the variable because you have already declared the variable. The program knows what the type of variable is. So you just have to call the name of the variable and assign the value. What you can't do is assign a different type. So if you declare a variable as an integer and then you would try to assign a string to it, you're going to get an error in C++ because it can't do that. If you try to assign a float, it's just going to forget the part after the decimal, right? So if you have an integer and you try to assign it 1.7, it's going to store it as 1. The 0.7 is gone forever.
So you don't have to say integer. You can just say 5.3 and it automatically knows that it's an integer when you declare it.
If you declare it as a type integer, right? So int is how you declare it as a type integer, int, and then you would give it a name, and then you would set it equal to some value. If you tried to set it equal to 5.3, it's going to store it as 5. It might give you a warning, but it should store it as 5. You also can't assign a formula to the name, right? You can assign these, it can do the math, right? So you set it name Adam plus character, it's going to store it as Adam character, right? It's not going to store it as Adam plus character. Does that make sense? It combines it into a single variable. This should say you can assign a formula. Sorry. Question?
So when assigning a variable, tell that it's a variable that exists, and then you can assign that variable a numerical value later.
If it's an integer or a float, yes, you can assign it a numerical value later.
And then later the code can tell it, okay, I want to add this A number, I want to add Adam, then add character, and then pop base down.
If it's a string, you can add Adam and then you can add character. You can't store Adam character in a variable that is designated for numbers. Does that make sense? So Adam is a string. This is the type, right? We talked about types last class. We're only going to worry about 4 types. There are other types, but we're only going to worry about 4 for this class. There are floats, which have decimals. There are integers, which is the type int when you're coding. Those are whole numbers. There are strings, which are things that have quotes. These are words or phrases or series of characters. And then you have booleans, which is designated by the BOOL type, bool, and that can be true or false. So if you declare a variable, when you're declaring it, you have to tell it what type of variable that is. If you're telling it that it is an integer type of variable, then it will not store anything that's not a whole number. If you try to put Adam into it, you're going to get an error. Does that make sense? It will if it doesn't. You can also assign a function. We haven't talked about functions yet, but every function has to return some value. You can use that function as the value for a variable. That's a really powerful thing. It's a really cool thing. We'll talk about that in depth at a later class, but knowing that you can assign a function to a variable is very cool. You can also assign a variable in a separate function or code. So if you have a function called player, you can access the score variable inside of player by using the period score, dot score. What this does is it says I'm looking in the function player and I'm going to find a variable called score and I'm going to use that. You can assign it to a specific variable inside of another function. We're not doing that right now, but it's important to know that functions can interact together. So constants. So up to this point, we've been talking about variables. Variables change. It's the nature of a variable. It can change and it should change. At some point during your code, the variables are what make the code do fun things, right? Otherwise, you're just saying hello world over and over again and nothing's changing. The cool part is that it can change. But you can declare something as a constant, something that is absolutely not supposed to change. So let's say you were writing a formula and you wanted to use the value of pi. What is the value of pi? And so forth and so on, right? That's a constant. It's never going to change. More importantly, if you write a code, you don't want anybody to be able to come into your code and change that constant because it would break all of the math that your code is doing. If you label it as a constant, then that value will not be able to be changed through code. They'd have to change it on this first declaration level, which is hard to do because you can make that private. For now, understand that the constant is generally something that cannot be changed. So you have public variables and private variables. Public variables are visible to other programs. So if we're looking at it, your username, right? Your Google username is a public variable because every program that you want to join says, would you like to use your Google name, right? You can connect to it. That's made it public to other variables. Private variables are something that it can't see, like your password is private. They can't see your password. All they can see is your account name. But this is true even within other programs. So if you're making a game and you have a, you can come in, it should be open. I don't lock you out because I want you to come in. Other people have different approaches to that. But as a general rule, if you show up to my class late, I would like for you to walk in. And it's more work for me to have to walk over and let you in, so I just leave the door unlocked. Otherwise, I'm going to have to tell Draken to go let you in. No, he doesn't want to do that. Did you get everything worked out? Almost? Okay. Counts for me. All right, so we're going to talk about planning now. And this is where things start to suck that I'm recording, because I really like to draw on the whiteboard. And this is where it's really fun if I have a camera that can show the whiteboard. Does that make sense? Because then I could just switch to recording that, and I could be drawing up here.
Unless you want to use MS Paint.
Well, I don't have to use MS Paint. I do have a feature on Zoom that could allow me to draw. I don't remember where it is. I can annotate, I guess. But we're going to try to do it just through conversation, and it'll be fine. Maybe I got a picture of what I do. So we're going to talk about an input, process, output chart. Now, everybody who codes, every person who has a career in coding has their own process for planning out their code, right? They might have their own technique for different things, but the general concepts are the same. It's a general three-step process. You have an input, you have an output, and then you have the process. So the input is what information do you have and what information do you need in order to solve the problem. The output is what is the value you need before you can end the program. So we talked last class about an algorithm. An algorithm has to have a solid start and a solid finish, a solid end. The output is what do you need before you can end your program. Does that make sense? The input then is what do you need in order to be able to get to the end. And then the process is how do you get from all the stuff you have to the thing that you need. So simple example is, let's say I ask you to write a program to find the we'll do this later, find the area of a square, right? What do you need? Well, the output is going to be the area of the square. That's what you want, right? What do you need in order to find the area of a square? You need the length of a side, right? What else do you need in order to find the area of a square?
Multiplication.
Yeah, you need multiplication, but you need a formula, right? Somewhere you have to define what the formula is to get the area of a square. And then the process is to use the length of the one side, right? Plug it into the formula basically, and then get the area of the square. That's it. It's very simple, right? But just like making that peanut butter and jelly sandwich, you have to be specific when you're going through this. So we'll look at an example from an IPO chart. You have 3 items and a sales tax rate. These are the things that you have. What you're trying to find is the total cost of these items. How much are you going to have to pay to buy these 3 items? To process it, you have to add all the item prices together. You have to multiply whatever that price is by the sales tax rate. Then you have to add the sales tax rate to the sum, and that will give you the total, right? All you're doing is adding these up and multiplying them times that to get your tax rate, and then adding the taxes to the overall price to figure out how much you have to pay, right? That's the process. But it has to be very specific, because when you go to code it, it has to be very specific. Does that make sense? And in theory, if you're working as part of a team, you might be the one doing this part, right? And then Ethan is writing your code. You have to make sure that Ethan knows what you want him to do, or he's going to mess up your code, right? You are. It's true. So one way to plan is the IPO chart. And you should certainly for what we're doing, the processes that we're doing, you should have an IPO chart because it will help you write the code. Some of the simple stuff we're doing, it's not necessary, right? But just to get into the habit, it's necessary. So then another way to plan is flowcharts. And we talked last class about the selection tree, right? Or choices, right? You want your code, at some point, it's not going to be straight linear. Your code's going to have to make some choices. These choices are all represented in flowcharts. Now, flowcharts have some best practice concepts that we want to be familiar with so that when we write a flowchart, anyone else who looks at it can understand what our flowchart is doing. A rounded rectangle signifies the start and the stop. That's it. If your rectangle is rounded, that is either the start of your flowchart or the end of your flowchart. Just like we talked about algorithms, has to have a start and a finish. The rectangle itself These are user or programmer input. A lot of the times when you write a code, you're going to give an input as the programmer. But just like last class when we had it say, hello, Adam, at some point you're going to be asking the user for input. Rectangles represent input that's been given to the code. An angled rectangle, this isn't a very good angle, but it looks like a rhombus or just a parallelogram, a rectangle that's been shifted. This represents the event that the computer does. So generally when you're talking about code, you have the user actions and then you have the computer events. And this is how we designate between the two. The computer doesn't usually have actions. The computer has events. The user or the player take actions, which cause the computer events. Now, sometimes the computer event can be an action that triggers another computer event. That does happen. But as a general rule, the thing that is happening is the event. The thing that is causing that is the action. That makes sense? Just terminology that we want to understand. And then a diamond signifies a comparison or some sort of a decision. And a diamond in almost every case, certainly for the start of this class, can only have two results. It can either be true or false because we work with Booleans. In a regular flowchart you might draw, there might be more than two options from every panel. In a flowchart for your decision tree, everything has to only have two possible outcomes. So everything we do when we interact with a computer uses binary storage. This really is important to know because we want to understand how the computer talks to itself. But we are very rarely going to interact with this. I know in assembly language, you probably lived in binary. I think you lived in hex. But we don't live in that space in C++ because it's a higher level language. But everything does have its binary association. I only have 3 slides left after this, but I'm going to open it up to questions about all of that stuff to begin with. I think the other 3 slides are projects driven, and I'm not sure those are the projects we're doing. We'll have to read it as we go. Questions, comments, concerns?
Back up that slide with the flowchart for a second.
Yes. You want to make it bigger? Whoa. That's as big as I can make it right now.
So you said the action is the cause and the event is the effect.
Yes. Yeah, so the thing that the user does is the user action. And the thing the computer does is the event. Sometimes the computer can cause the computer to do other stuff, and then the computer gets to be the action and the event. But the thing doing is the action, and then what the computer's response is the event.